Link from GoDigitalSA Foundation. Today we're doing Unit 6, the mini project. Lesson A will be looking back at what we've done so far. What we'll learn, just a review of the computer science concepts we've covered so far. Then we'll have a chance to brainstorm. So the project overview, you will use the design thinking approach to create an original project that serves a purpose by solving a problem or filling a need. Show what you know, learn and demonstrate something new, include a maker component, demonstrate the use of the following concept: design thinking, input, processing, and output, variables, conditional statements, iteration. So, concept reviews. In Unit 1, we talked about making. In Unit 2, we talked about processing and algorithms. 3, variables. 4, we talked about conditionals. And in Unit 5, we talked about iteration and looping. Okay, so you should be able to name one thing that you've learned from each of these units. Okay, so in Unit 1, we talked about making. Microbit is very effective at bringing things to life. It can be supported in a cardboard holder attached to a wand or even sewn into fabric. Clothes. The design thinking process is a helpful way to create an optimal solution that will solve a problem or address a need. Design thinking process steps are empathize, define, ideate, and prototype. You should remember, empathize is learning about your audience. Define, construct point of view based on user needs. Ideate, brainstorm and come up with creative solutions. Prototype, build representation of your ideas. And test your ideas. Okay, processing and algorithms, you'll remember this. 4 parts to a computer: the processor, which has got the CPU, the central processing unit; memory, which we've got long-term and short-term storage; inputs, like keyboard, mouse, microphone; outputs like printer or speaker. The code you write for the microbit processes data from its inputs and outputs it in some way. Algorithm is a series of specific instructions or steps that solve a problem or accomplish a task. The variables store information so that it can be accessed or referenced later. Some variables hold information that changes, and some hold information that stays constant. It is important to name your variables with something that explains what type of information it holds. Variables can hold information of different types. In make code, we've got numbers, strings, text, Boolean, which is true and false, sprites, which are the LEDs on the display, and arrays, list items. Okay, here we see that in make code on the start block, we've taken these variables that we created and we're setting them to a value. So we created a variable called number variables and set it equal to a number. Created a variable called string variable, which we set to a string. Variable Boolean variable we set to true. Sprite variable we set to a sprite, which we created at position 2, 2. And variable list set to an array of red, orange, yellow. A conditional statement is a rule or criteria that must be met for an action to be carried out. Conditional statements are written in the form of if, then, and sometimes if, then, else. Conditionals are used to tell a computer when to do something. And remember that you can have nested conditionals. You can say if this, then that, else, if something else, then this, else, if something else, then this, else. Okay, iteration and looping. Iteration means repeating a process or sequence of steps. A loop allows you to repeat lines of code, making your programs more efficient. There are 3 types of loops in make code. The repeat loop repeats a certain number of times. For loop, which repeats based on an index variable, which increments each time. While loop, which repeats until a certain condition is met. And there's actually a fourth loop, which they haven't listed here, which is the forever loop. The forever loop is repeated forever. So long as the microbit is turned on, for loop will carry on repeating. Okay, the mini project Brainstorm. You will be creating a mini project with a microbit that incorporates all the concepts we've covered so far in class. So if you've got some friends you're working with, then you can get into a group to brainstorm ideas for your mini project. Think about all the concepts we've covered so far and think about how your project could solve a problem or fill a need. Okay, so what we've learned, taking a fresh look at the computer science concepts we've covered so far, and we've brainstormed for the mini. Next time, B will code and make a mini project. Okay, so lesson B, coding and making the mini project. Okay, we'll talk about design a project and building it. The mini project, we want to design a project that serves a purpose by solving a problem or filling a need. You need to show what you know, what you knew, and include a maker component. Project expectations, use a design thinking approach and ensure the project meets these specifications. Create an original project using the microbit. Incorporate a physical component to the project. Demonstrate the use of the following concepts: design thinking, input processing output, variables, conditional statements, and iteration loops. Some project ideas: we can have a new and improved fidget cube. You can make a moving monster, make a musical instrument, fishing game, air guitar, a screensaver, an interactive book, game, or binary clock, some other way to represent numbers visually. Here are some project examples. Toss the ball. This is a skill game in which an aluminum foil ball is thrown into a plastic cup. Copper tape lining the sides and bottom of the cup completes the circuit when the ball touches it. Okay, so in this case, you can see we've got these three cups. They've got wires, copper foil, which make conductors. So if you throw this ball into this cup, it should touch the two, which closes the circuit. If we've connected that to a microbit with crocodile clips, that can be on our P0 connector, then that can tell the microbit that P0 is closed. Likewise, this can go to P1 and this can go to P2. Okay, we'll take a look at that just now. Another project example, microbit is Bullseye. This is a skill game in which tennis balls are thrown underhand at one of the three rings, which are lined with aluminum foil, so they complete a circuit underneath when the ball makes the ring. Okay, so same thing. By throwing a ball at these rings, they are connected to the microbit, and they can be connected to P0, P1, and P2, so that you can have a program that will detect which one of these rings. A storybook is the prototype of a storybook that could use the microbit to display animations for part of the story. The copper tape is used on the underside of the paper flaps to make contact between the ground pin and each of the other pins in sequence. Okay, so here we've made a story, and you can touch these buttons which will make contact to the pins P0, P1, and P2, and that can display something on the microbit. Okay, so we've talked about designing a project and building it. Okay, so let's open a browser and start coding. Okay, so we've opened up a browser. We've gone to makecode.microbit.org. We're going to create a new project. We'll call this project mini project. Okay, now we're not going to make a project here. I want to show you some of the blocks that we can use when we make a project. So you'll remember whenever we create a new project, we start with a design surface, which has got an onStart block and a forever block. OnStart block contains code that will be run once when the microbit starts. Forever block contains code that will be run in a loop forever, as long as the microbit is running. These blocks are optional. If you don't need the forever block, you can take it away. If you don't need the on start block, you can take it away. Okay, so let's go through all the blocks in the toolbox. So in the basic drawer, we've got show number, show LEDs, show icon, show string, clear screen, forever, on start, pause, and show arrow. Okay, so the forever and on start we can drag onto the design surface. We can't put these other blocks on the design surface. You'll see it comes out gray because it isn't doing anything on the surface. Something needs to run this. We put it inside a forever block, then this show number will run forever. See that here, it's displaying 0 and it will always display 0. You take a show LEDs, make a pattern here. Now we'll see that our forever block will display 0, then it will display this pattern. And then it will go back and display 0 and the pattern, and it will do that forever. Take show icon. We can choose one of the existing icons to display. Okay, and you'll remember that we used this for rock, paper, scissors, but we can display any of these icons. For example, this one. You can see display 0, symbol, and then the icon. Show string will show a string. So here we've got the string hello. See, because it's got more than one character, it will scroll characters one at a time. Let's just take these away. Just the string. Now it's going to show the string forever. And of course, you can change the string, make it anything you like. Plays. Bye. Okay, we've seen that clear screen clears the screen. So if we displayed number, icon, string, display the number, the icon, string. If we say clear screen, clear the screen. Plays each of these in turn, clears the screen, repeats. Go down to pause, you can make it pause, get it to pause for, let's say, 1 second, 1000 milliseconds. You'll see that it will display each of these. Clears the screen, and then it waits for 1 second before it repeats. Okay, and finally we've got show arrow. Move all of those. Okay, so show arrow north. Wait a second before it loops around. So show arrow north, it's pointing north. Point northeast. East. So on. Okay, so those are the basic blocks. Okay, next we've got the input blocks. We've seen on button A pressed, button B pressed, button A plus B. So we can say for the string, show LED. So on button A pressed, get it to display A. Okay, you'll see now it's not doing anything. If I press button A, it displays the A. If I press button B, nothing happens. Go back to input, drag out another one. Remember, if we drag out the same one, second one won't work. It's grayed out because you can't have the same handler routine. I'm changing this now from an A to a B. This will work. They show LEDs. B. Okay, letter B. Now when I press the letter, the B button, displays a B. A button displays the A. And remember, we can also have button A and B pressed at the same time. If I change this to A plus B, that means button A and button B are pressed at the same time. Now we can display something else. I'm going to display A plus. Okay, so when you press A, it displays A, B displays B. And because our mouse can't press both buttons at the same time, the emulator has given us an A plus B button. On the real microbit, we would physically press the A and the B button at the same time. But on the emulator, we're going to press this button, which means A plus B, displaying the plus. Okay. We've also seen on shake. On shake, we can do something. I'm going to display letter S. Again, on shake means you shake the microbit because you can't shake the emulator, giving us a shake button here. So if I press the shake button, it's like shaking the microbit, and it displays the S. Okay, let's just look at the other things quickly. So we've got logo up, logo down. We get screen up, screen down, tilt left, tilt right, free fall. So you can actually physically drop the microbit, but you should do that on grass or on something soft, like a pillow or cushion. Don't drop it on the ground because it can break. And you can also get it to detect different forces of dropping it. So have you heard of G forces? 1G force is the force that you feel when you're on the ground. 2G is twice that force. 3G is 3 times as much. 6G is 6 times as much. And 8G is 8 times as much. So we can get it to detect how hard it falls. But again, do this on grass or on a cushion. Make sure you don't drop it on something hard because it will break. Okay, so we can detect all of these events. Okay, we've also got on pin P0, P1, and P2. So we can get it to detect when one of these pins is touched. What does this actually mean? Okay, so if I've got pin P0 is pressed, it will display a 0. What does that mean? It means if I touch pin P0 with my finger, then it will do whatever is in here. And it can detect different levels of touch. Now, what it's doing is actually a little bit complicated, but depending on how hard you press the pin, it comes up with a signal level, which simply tells it that that pin has been touched. So you can do this for pin P0, pin P1, and pin P2. Okay, so if you touch pin P0, is 0, touch pin P1, 1, pin P2, plays a 2. Okay, so you'll remember that we said that we've only got two buttons, button A and B. So we can detect if button A is pressed, or if button B is pressed, or if button A and B are both pressed at the same time. But now we can also say if pin P0 is pressed, or pin P1, or pin P2. So this allows us to have more inputs for our programs. Okay, what else have we got here? These are all event handlers. Okay, so if you press pin P2, everything inside this block will happen. We've also got conditions. Here we've got a condition. Button A is pressed will be true or false. Remember, we used this in one of our projects. We've got pin P0, P1, P2 is pressed. As a condition, it'll be either true or false. Shake, gesture, or any of these gestures. Okay, so these are conditions. Remember that under logic, we've got if something is true. So we said if here we got shake, but we can have any of those other ones. So we can say okay, so this says that, okay, let's put this inside the forever rather. On this forever, if shake gesture is true, then it will show these LEDs. And this is inside a forever loop, so it's ever checking to see if shake is true. So if we shake it, it displays the 0. Okay, and if I say else, and we have a clear screen, what's going to happen here? If we shake it, it displays 0, and then you see it's cleared. Because inside this forever loop, it's forever checking to see if it's shaking. If it shakes, it shows this. Otherwise, it clears the screen. So as soon as we stop shaking, the next time around the loop, the shake is false, so it clears the screen. Okay, so the conditions we've got here is on buttons pressed, on pins pressed, and on gestures, shake, any of those other gestures. Inputs also include variables. We've got variables for acceleration, light level, compass heading, and temperature. So let's say forever we will show a value. Okay, so if we show number, it will show 0. If now we go to a value of acceleration, okay, I'm not doing anything, so acceleration is 0. If I start shaking this, the acceleration changes. The emulator shows us what the acceleration is. And it also shows us the axis, direction of the acceleration. So this will display now, we're showing the number, the value of the acceleration. We can show acceleration in the x direction, or in the y direction, or in the z direction. So x is left and right, y is backwards and forwards, z is up and down. Or we can show the strength of the acceleration. So here, the more we shake it, the larger the number is. So here, we're using acceleration as a variable. We can also have light level as a variable. Here we're going to show the light level. And in the emulator, I can make it light. Shows 255. Make it dark. Shows 0. And I can make it anywhere in between. Okay, and then it will just show that value. On the real microbit, it will be showing how strong the light is that is shining on the microbit. Okay, then we've got compass heading. Okay, with compass heading, it shows us the direction that it's pointing. If the microbit is pointing north, then the heading is 0 degrees. If it's pointing east, the heading will be 90 degrees. And again, in the emulator, we're changing the direction. But on the real microbit, you would turn it in that direction. Okay, so here it's showing about 90 degrees. If it's south, it'll be about 80 degrees. Point it west, be about 270 degrees. Until you get back to north, which is 0. Okay, so that's compass heading. We've got temperature. Okay, the temperature is the temperature of the microbit. Again, here it's showing 21, and we can get the emulator to show different temperatures. 50 degrees, -5 degrees, anything in between. And again, the real microbit will show you the actual temperature. Okay, that's the most common inputs. There are more inputs. We've got rotation. And rotation can be either pitch or roll. Pitch is how much the front end points up or down, and roll is how much the left or right sides are up or down. On the emulator, we can point the nose down. We get a negative number. Or we can point it up, positive number. Notice that left and right shouldn't affect that. If we do roll, that's how much points to the left or the right. So if the right side is down, it's a positive number. Left side is down, it's a negative number. Okay, magnetic force. Remember that it's got a compass built in, so it can measure magnetic force, and normally it's measuring the magnetic force of the Earth. Again, it can show it in the X, Y, and Z direction, or it can show the strength. Okay, and in this case, the emulator won't show us anything. The real microbit will show us magnetic forces. We got running time. Running time is how long the microbit has been running for. Is in milliseconds. Here you can see it's been running for 860, 1,300, 13,000 microseconds. Okay. And it's not very useful displaying this, but you can use this to make a stopwatch or something else that requires the time. Okay. Then we got two special blocks here: calibrate compass and set accelerometer range. Okay, so if we got calibrate compass, we typically do this to calibrate a program. So we could say when we want, before we start using our program, we want to calibrate the compass. We can say if A and B are pressed, then we calibrate the compass. Okay, so when we do this, then it will calibrate the compass. Here we've got set accelerometer range. Range can be 1G, 2G, 4G, or 8G. Okay, so this just sets the maximum value that it can measure, the accelerometer. Okay, those are the inputs. Okay, I think we're out of time now. So let's pause here, and then we'll carry on with part 2 of Unit 6, where we'll look at music, LED, and radio, as well as math and some advanced features of Microsoft Make Code for the microbit. So until then, I'll see you next time.